So let's look at Descriptive Statistics, Chapter 2, Sections 2.1 through to 2.3. So let's see what we have here. Let's look at some definitions we've got. Data. What is data? Data is just the facts and figures collected, analyzed, and summarized. It's just anything that we collect that's going to help us make a decision. It could be numbers, it could be words, it could be preferences, it could be anything. What's a variable? A variable is a quantity that can take on any different values. So basically anything that is subject to change is a variable. Anything that takes on more than one possible value. An observation is an outcome to an experiment, and a variation is how values change. So let's look at this. We've got the Dow Jones Industrial Index for a bunch of companies there. And we see that we've got company name, and so the company names are all different. Each company has a symbol, so that they're all different. So these are variable. These are variables. The industry, they are variable. They take more than one value, even though you do get some industries like some companies like IBM and Intel. They're both in the technology industry, but again, it's still a variable. The share price, they're different. They're variables, and the volume are variable as well. So this type of data is actually called cross-sectional data because it's a snapshot of data at one point in time. That's not the only type of data that we can have, as we will see shortly. Let's move on. So this is what we're going to look at here. Types of data, starting off with population. So what is a population? Population is all items. This is my population, and I've got everything that makes up my population in here, and it's all items of interest is what my population is, all elements of interest. What is a sample? A sample would be a subset of the population, so it would be everything in here. And in earlier stats courses, you would probably discuss the ideas about how you construct a sample, a simple random sample, stratified sample, and also the idea about sample being biased or representative of the population as a whole. But a sample is a subset. Quantitative data, what is quantitative data? Quantitative data is just those numbers and that we can add, divide, subtract, multiply, and perform all the regular calculations that we typically do, say with money or something like that. They're the numbers that we're used to dealing with. The numbers actually mean something. As opposed to categorical data. Categorical data is just when you split data by categories, or when you just label items. So for example, if I'm doing an experiment and I'm looking at males, and let's change that, I'm looking at males and I'm looking at females. And what I want to do is run some sort of experiment, some sort of analysis on that. I may say that males are going to be represented by a 0 and females by 1. If I want to actually input this data into a computer, I'm going to have to do that. Computers don't understand M and F. So this would be categorical data. The 0 and the 1 I just chose randomly because they have no significance other than to say that there's a difference between 0 and 1. There's a difference between male and female. They're different categories. In fact, it makes no sense to add them together. If I was to say, if I have a male and a female, if I add them together, 0 plus 1 equals 1, that would mean that doesn't make sense. 0 plus, that would just be a female. It doesn't make any sense that they're labels. So with categorical data, they're labels, and even if they're represented by letters or numbers, the numbers don't actually make any sense. You can't really add and subtract and divide them, as opposed to quantitative data where the numbers do make sense to do those things with. The data we looked at earlier for the Dow Jones was called cross-sectional data because it was a snapshot of all the share prices at one moment in time. Data doesn't have to be given to you like that. Data could be also given to you as a time series. So time series data is data collected over several periods of time, and it helps us understand what happened in the past and helps us project what's going to happen in the future. So basically, if I am looking at again, if I'm looking at my sales, suppose I've got a pizza place nearby and this is time. A time series data would be looking at my cells over a period of time. Hopefully my cells are increasing. I can look at that. I can understand what happened in the past, and hopefully it's going to help me predict what's going to happen in the future. When we move on to the next slide, we've got the Dow Jones now, but the Dow Jones is not giving us a snapshot, but it's giving us a time series of data. You can see the data as it's changing over time. And so this is time series analysis. We can actually see what happened in the past, and we can try and predict out to see what's going to happen in the future over here. We can also see what happened in the past. We can see around 2008, the market began to, from a peak, it began to fall down and went down. It was really low in 2009. It took it quite a number of years before it recovered to come back to the levels it was at before. So we can get a lot of information, both historical and also help to predict what's likely to happen in the future. So where do we get our data from? Let's have a look. Well, we can have an experimental study to get our data. An experimental study is I set up an experiment, like, I've got an unmarked cup here with a soda in it, and another unmarked cup here with a soda in it. One's got Coke in it and one's got Pepsi in it. I won't tell you and ask you to do the challenge, the Coca-Cola challenge. The Cola challenge. So they're setting up an experiment. I have full control over the experiment. I could have chosen Sprite and Mountain Dew or 7-Up or something else. I have control over the experiment, and that's the key feature of an experiment. I can also collect data by using an observational study, and an observational study, like an example of an observational study, is just basically counting, for example, how many airplanes fly overhead in any 24-hour period. That's an observational study. I have no influence on how many airplanes fly overhead. I'm just sitting back and observing. If I was to go to a mall and I was to ask people, how many times do you go on social media each day? That would not be an observation. That would be an observational study. Because I'm observing what they're doing. I'm not influencing what they're doing. I'm asking them, what did you do? I'm observing what they've actually done. So observational studies you don't have any control over, whereas experimental studies you do have control over. So supposing we go to a restaurant, and at the end of the evening, when we've finished at the restaurant, they come back and they give us this piece of paper to fill in to see about our experience at the restaurant. What sort of study would this be? What the data we're collecting, would it be experimental or observational? Hopefully you're thinking it's observational, because you're just observing what people's reactions were at the end of the evening. You're not influencing their reactions. You're just saying, I would like to know how your experience was, and that's it. And they're going to fill this out. So this would be an observational study. And the response categories would also be, in this case, categorical. They're not quantitative, because we're looking at excellent all the way through to poor. And so they're just categorizing your responses. Even if instead of excellent, it had 1, and it had 2, and 3, and 4, and 5. So 1 being excellent, 5 being poor. Those numbers don't mean anything other than to separate off the different responses. So now we're going to look at modifying data. And to modify data using Excel, we're going to use sort and filter, and we're going to use conditional formatting. To do this next exercise, you will need to open up an Excel spreadsheet with the name Motorcar Excel Data. So that's the one I'm going to actually look at right now. And there it is right here. So what is this? What is it that we're looking at right here? We're looking at car sales for 2011 over here. In 2011, we're looking at the car sales, and the top 20 for the top 20 cars. We've got the manufacturer, the model. These are the sales, and you can see that they're sorted by 2011. So sales at March 2011 of Honda Accords were 33,616. For Nissan Altima, 32,289, and they go all the way down to the Ford Fiesta in 20th place. They sold 9,787 cars. We also have the car sales for the same point in time for the previous year. The first thing I'd like to do is I'd like to add in the percent change in sales, the percentage change in sales, let's put it in here, the percentage so the percentage change in sales from 2010 to 2011. Okay, that's what we'd like to do in here. So how am I going to do that? I want to see how much the sales changed by it. Here they increased. I don't want the amount, I want the percentage. So the way I'm going to do that is I'm just going to put a little formula in here, and it's in fact going to be equals to, it's going to be equals to the sales in 2011, where they're at, and where did they begin? Let's subtract the sales of where they began. So this is the increase in sales between 2010 and 2011. And to get the percentage increase from 2010 to 2011, I have to divide that out by the sales in 2010, and that gives me the percentage. So the increase in sales of 15.4% for the Honda Accord between 2010 and 2011. And I can go all the way down here and put that number in. I've got to divide by 0 down here, and that's because there was no car sales for the Ford Fiesta. So either it was a new model in 2011 or it just wasn't recorded before. So I get rid of that divide by 0 and just put a blank in there, just put a dash in there to make it seem that much easier for me to look at. So what I'd like to do is now sort the car sales by 2010. Right now they're sorted by 2011. Honda Accord is in #1 position. Nissan Altima #2. Toyota Camry is in 3rd position. And it's interesting to see that the percentage increase in sales for the Honda Accord from 2010 to 2011 is 15.4. For the Nissan Altima, that increased as well. It's notable that Toyota Camry had a big decrease in sales. They went down by 13%. Some cars went down, but not many of them. The Ford Focus went a little bit down, and the Chevy Malibu went down, and the Nissan Versa went down. But all the other cars went up, and some of them showed massive increases, like this one right here, the Nissan Sentra, had a massive increase, and so did the Hyundai Elantra. So what's going on? This would be kind of interesting to analyze this data and figure out what's going on. So what I'd like to do is rearrange this data and sort it by the previous year's figures. So what was #1 last year? It's kind of difficult to see which car was in first place in March 2010. So I have to go down there and find the largest number. I guess it was the Toyota Camry. And which one was in second place? It becomes kind of difficult to do that. So there's a way that we can just do that in one fell swoop. And the way we're going to do that is we're going to highlight these cells A1 through to F21. And then we're going to click on the data tab up here, right there at the top, the data tab. And then we're going to go to sort. In the sort and filter group, we're going to hit sort. And depending on which type of computer, if you've got a MacBook Pro, or if you've got just a PC, they may be slightly different. They're very similar. The output here would look very similar. I'm actually using a MacBook Pro, even though I'm used to using a PC. And it's fairly easy to navigate on, so let's not get caught up with that. So we want to sort everything by sales, not for March 2011, but for March 2010. And so it's as easy as that. Now notice I highlighted everything. If I just highlighted the sales column, it would just rearrange the sales column and leave everything else fixed in the same position. So I want everything to be rearranged. I just don't want this column to be rearranged. I want everything to be rearranged because it would be a big mess if I didn't do that. It would just be a jumble of data. So I want to rearrange everything by the sales from March 2010. And I can do smallest to largest, or I could do largest to smallest. Probably let's do largest to smallest. And let's press OK and see what happens. That's great. So what we've seen now is that last year, indeed, as we picked out, is that Toyota Camry was in fact in #1 position, and it had a 13.2% decrease in sales, which is about nearly 5,000 cars. It sold fewer from March 2010 to March 2011. The sales decreased by 4,700, nearly 5,000 cars less. So it's interesting when you do things like this, because you can begin to see things in the data. You may ask yourself, why did that happen? What happened? Why did Toyota Camry go from #1 position to #3? Why did the Honda Accord, its main rival, have an increase, basically picked up pretty much all the loss that Toyota Camry made? Why was it picked up mainly by Honda Accord, its main rival? Did anything happen? And if you actually look into the history, what you'll find out that there was a big problem with Toyota Camrys in 2010, between 2010 and 2011, where they had an issue where the accelerator was sticking and a lot of people were having accidents. The accelerator would just jam down, and they couldn't get it up. And in fact, there was fatalities because of it, and they lost a lot of market share. And people went over to Honda Accord, which was pretty much its main rival. That's interesting to see that when you see little things popping up in the data, then you can start analyzing and looking behind them to see what happened. So how about, supposing I just want to see the Toyota sales. So what I'm going to do, I only want to see the Toyota sales. Is there a way that I could filter out and just see the Toyota sales? And yes, there is. Again, I'm going to highlight all the data like this, A1 to F21. I'm going to make sure I'm clicked on the data tab at the top, and then in the sort and filter group here, I'm actually going to press on filter, and if you see, it just included all these drop-down menus. Now I only want to see Toyotas, so Toyotas is manufacturer, is in the manufacturer column, so I'm going to click on here, and so I can either try and just deselect each one and just leave Toyota clicked, or what I can do is if I press this button here, I will deselect everything and I can just go down to Toyota, click on Toyota, and then all I've got is the Toyota sales. So I've just filtered out everything so I can see Toyota. I could have just seen Toyota and Mazda or whatever it happens to be. I could have filtered it as I wish depending on which choice I made from this drop down menu. I could have chosen whatever I want. I can choose multiple cars or just a single car as I did. So the last thing we're going to look at here is conditional formatting. And conditional formatting just makes it easy to identify data that satisfies certain criteria and certain conditions. So I'm going to just revert this back to where we were at before, press the back arrow a couple of times. And what I would like to do here is identify all the cars that had decrease in sales between 2010 and 2011. Now it's fairly easy to do here because I can see, look, this one decreased, this one had a great decrease, this one had a decrease. But typically we're not just dealing with 20 cars, 20 categories, we may be dealing with thousands of categories, and it becomes very difficult to do that. So is there a way that I can identify using conditional formatting those cars, for example, that had a decrease in sales from 2010 to 2011? So yes, there is. And the way we're going to do that is we're going to hit the Home tab up here. And then we're going to look for conditional formatting, which is here. And on conditional formatting, we can see the highlight cells rules. So I want to highlight all the cells. I want to identify by highlighting all the cells that had a decrease in sales, so that the sales were less than something. And the decrease I'm actually looking at is that it's going to be less than 0. So if there was a decrease, if the figure is less than 0, it's going to identify it. You can choose how you fill it. You can play around with it. It's defaulting to that red. You can change the color to yellow or whatever you want it to be. And let's press OK. And let's see, let's just do that one again. Conditional formatting, highlight cells greater than, less than. And let's put the 0. We didn't put the 0 in here. Let's put the 0. And let's press OK. And the problem I've made here, is it's supposed to highlight everything first. There you go. Now, I don't have to highlight the whole the whole area, because I'm only interested in highlighting. I'm not rearranging anything here, okay? So I'm just going to highlight what I want to be picked out, the area that I'm interested in. So conditional formatting, let's try third time lucky, less than, and I've highlighted everything. I'm going to put my 0 in here, and I press OK, and hey presto, there you go. So these are the actual ones that have a decrease in cells, and it's fairly quick to identify them. You don't just have to look at decrease in cells. There's other things that you can look at. In fact, when you're using Microsoft on a PC or a laptop that's not an Apple product, when you actually highlight this, down here you're actually going to get a little quick analysis button that allows you to do this quick analysis. It's just quick to do anyway, as I've just shown. That's the end of Chapter 2, Sections 2.2 to 2.3.